Today we're going to start chapter 2, section 2.1, relations and functions. Now to start with, there are some definitions here you need to be aware of. The first one is domain. So domain, and I apologize for the glare on the whiteboard. The domain, the input values of a relation, also known as the x values. It's just a fancy way of identifying all of our possible x values. The range is the output values of a relation, also known as the y values. So sometimes we mix them up, what's domain and range? I like to remember them using the alphabet. D comes before R, input, or the I comes before the O in output. X comes before Y. So that always helped me to understand which one came first. Now, when we're talking about domain and range, we can express them in 4 different ways. Ordered pairs, we're given like the x and y value, we just keep listing them as ordered pairs with parentheses around them. We can list them in a table. All the x values are domain on the left, all the y values are the range on the right. We can do a mapping, and I'll show you how to look at that when we're looking at evaluating functions. Pretty much we have values on the left that are connected with values on the right with arrows. And then a graph. Graphing our ordered pairs to see where they situate on a graph. Now I included a word problem in attached notes. When skydivers jump out of an airplane, they experience free fall. The following information is given. You can go back and look at all those things, all the data. Now with the data, we first have to identify what is our domain and what is our range. Now, again, what comes first? Can we have one variable without the other? Can we do an event like jumping out of an airplane without time? I don't think we can do that. Can we have time but not jump out of an airplane? Yeah, we can always have time. Typically, we can't do anything without time, so time will be our domain or x values. So I kind of wrote it out here, the 4 different examples. Ordered pairs. Again, listing them all 5 down. 0, 10,000. 4 seconds, 9,744 feet. 8 seconds, 8,976 feet. 12 seconds, 7,696. And 16 seconds, 5,904 feet. Now I can list them as a table. Again, all the x values on the left, all the corresponding y values that go with them are on the right. And then we have the mapping. Okay, I'll bring this a little closer so you can see it. So the mapping, all the x values of the domain are on the left, and you can see arrows that they're going to the values on the right. Now it's just coincidence that all the lines are going across. They can be going in different directions as long as they're hitting an output value. And then there's our graph over here. The domain or x values are on the bottom, as we know, and the range of the y values are going up and down. And then here's our graph to kind of see what that looks like. So we can arrange using any of the 4. Some of it, depending on what your teacher's looking for or how you want to do your presentation, is kind of up to you. Now there's another word that we need to be familiar with. Probably one of the top definitions you need to be aware of. It is called function. Now there's a lot of functions in life. A lot of things can be defined with a function. There's some things that are not functions, and we'll see examples of them. But you need to write this down and think about what this means. Function. It is a relation in which each input has exactly one output. I've talked to college professors, and what they recommend to us math teachers in high school, we need to focus more on domain and range and how these are related. So keep this in mind. Each input has exactly one output. Not 0, not 2, not 3.5, but one unique output. If it has more than one, then it is not a function. So we're going to start by looking at some mappings. Here's our domain on the left and our range on the right. Now I'm just going to use simple numbers like 1, 2, and 3. Over here we'll make it 10, 20, and 30. Let's say we put 1 in our function, we get 10. We put 2 in our function, we get 30. 3, we get 20. The arrows kind of dictate the input followed by the output. Now, we ask ourselves, does each input only have one output? One arrow here, one arrow there, one arrow there. This is a function. Let's look at another one. Let's start with 1, 2, and 3 again. This time, we only have 10 and 20. Let's say 1 goes to 10, 2 goes to 10, and 3 goes to 20. So as an ordered pair, this would be 1, 10, 2, 10, and 3, 20. Is this a function? Well, let's see each input. Well, that has one output to 10. This 2 has one output, but it's going to the same 10. 3 has one output going to 20. So some of you might think, oh, well, it's going to 10 twice. But does each input have exactly one output? Yes. This is also a function. Now in this example, let's say 1's going to 0, 2's going to 0, and it's going to 2, 3 is going to 1. Now, our input of 1 has one output going to 0. But look at what 2 has. It goes to 0 and it goes to 2. So, this has two outputs. This would be an example of not a function. So we have an ordered pair of 2, 0 and 2, 2. So keep that in mind. So let's compare now a couple tables. One's going to be a function, one is not. Say we're given information of 1, 4, 2, 5, 1, 6, 7, 8. On the second one, we have 1, 2, 2, 2, 3, 4, 4, 4. Which one's a function? Which one is not? Well, if we look at this one, I have an x value of 1 going to 4, and also down here I have 1 going to 6. I have the same input of 1 going to 2 outputs. So this one does not have one unique output, exactly 1. It has 2. Because these have the same input or x value, make this not a function. So if we were doing a mapping, there would be 2 arrows coming from 1. Over here, 1 going to 2, 2 going to 2, 3 going to 4, 4 going to 4. We don't see any of our x values repeating. Therefore, this one is a function. In tables or ordered pairs, if you see the x values repeat, it means it is not a function. So looking at those, that's how we can identify different relations are functions or not. Now let's consider graphs. So I'm going to draw 4 graphs here. Okay. Now, how do we know if these are functions or not? Remember, each relation, a relation in which each input has exactly one output. Now, looking at graphs, we want to use what we call the vertical line test. Remember, a vertical line goes straight up and down. Okay? Vertical, kind of like your vertical jump, you're going straight up and down. Now, it passes the vertical line test if it hits the graph only one time. So we have this funny looking graph. As I take a vertical line and run it across the board, you will notice that it's hitting the marker at one time and one time only. Therefore, it passes the vertical line test. It's only hitting once. This is a function. If we look at number 2, so going with my marker, and whoa! Right here, it's hitting it more than once. So if I drew a vertical line right there, it's hitting at that spot, and that spot. It's hitting in 3 spots. Therefore, this fails the vertical line test, and this is not a function. Now, if we want to compare it to an ordered pair, these values, this one might be, say, 5, 6. So let's say this one's 5, 6. This one might be 5, 0. This one might be 5, 10. If you see, these x values are repeating. Okay? Also, keep in mind, a vertical line is not a function. Hopefully remember that from the slope of a line that goes straight up and down, how it was undefined. That's because it's not a function. Looking at the W, I'm seeing that it's hitting it only once. So this is a function. And then finally, looking at the circle, I'm going, whoa! There's a vertical line. It's hitting it twice. So every circle is not a function. It fails the vertical line test. This test will work every single time. It will also work if there's just random points drawn. Again, if there's a point here and a point here and the same x value, not a function. So remember, definition of a function. Think about domain and range. It begins our beginning points or end points. And then use the vertical line test to evaluate if you're given a graph. Hopefully this helps. See you next time.